Hi, I'm Gary Moore. I'm the leader of the National Plant Data Team with USDA NRCS. I'm going to be talking about plant taxonomy in general and plants database taxonomy in particular. The plants database as a website went online in 1994. As a database, it's been around since the 1980s. And a checklist, which formed the basis of the database, was published in 1971. The mission of plants is to document information for all of the plants occurring in the United States, primarily outside of cultivation. There are three ranks that are the focus in the plants database, and those are the family, genus, and species. What you're looking at there are a couple of pages, one for the family Rosaceae and another for the genus Cypripedium, the rose family, and lady slippers respectively. The pages, profile pages for families and genera are aggregates of all of the information for the subordinate taxa or the genera and species that occur in a family or the species that occur in a genus. The bulk of the data collection occurs primarily at the species level. And so the species profile pages are most information rich. They have a lot of information in there, including a good deal of information on characteristics. And Chris Taliga is going to give another talk about characteristics in the plants database. Can't get too deep into plant taxonomy without a reference to the International Code of Nomenclature for Algae, Fungi, and Plants. There are two principles I want to highlight here. Each taxon, such as a species or a genus, with a particular circumscription, position, and rank, can have only one correct name, the earliest in accordance with the rules. Also, the applications of names of taxa are determined by means of nomenclatural types. It's important to note that the code does not dictate how one should do taxonomy. It strictly dictates how one should apply names once you have a given fixed taxonomy that's agreed upon. Plants upper level taxonomy. There's not a lot of information provided for the upper levels. We do have profile pages for families, which have a fair amount of information. But once you get above the family, the only information you're going to find is in the classification table at the bottom of profile pages, where a taxon's placement in these higher levels, such as order on up, the actual names are given in that classification table. But that's all the information we provide once you get above family. Note that the family and above ranks, they're all monomials. The primary ranks have fixed endings, so all families end in ACE, all orders end in ALEs, etc. So you can look at a given upper level name and know what rank it belongs to just by looking at the name and the ending. The upper level classification system used in plants goes all the way back to Arthur Cronquist, who passed away in 1992 when the website went up live. A modified system of his upper level classification was used, and it has remained in plants ever since. That's due to two reasons, primarily because it's been difficult to do a large update like that in plants recently, although that is changing as we develop content management for plants. And also, in the 1990s and in the 2000s, there was a great deal of research done on plant phylogeny, primarily using DNA data. And so over those few decades, we've learned a lot of new information about upper level plant taxonomy. So now is a good time to update the upper level plant taxonomy in plants. The lower level plant classification will take a little bit more time. We've got thousands of genera that are in plants, many of which require review of their taxonomy. We've got tens of thousands of species, many of which also require review of their taxonomy. Before I get into some of the name changes that we're seeing in plant taxonomy, I do want to talk about the fact that there are big swaths of the plant taxonomy landscape are quite stable, and I'll just give you a couple of examples. One example is the plant on this slide, skunk cabbage. It was given the name Symplocarpus foetidus in 1817. It has kept that name ever since. Reason being, its circumscription has remained stable, its position in the genus Symplocarpus has remained stable, and its rank as a species has remained stable. All those things remain stable, and the name will remain stable. Other examples of stability in taxonomy at the upper level are some of the families. The composite family, Asteraceae, is a very stable family name, as is the grass family, Poaceae, very stable group. However, there have been changes in other areas of the taxonomic landscape. And so I want to focus on when we're seeing these changes due to changes in rank first. And I'll just use one example, the smartweeds. These were once treated as Polygonum section Persicaria. So they were a distinct, discrete section in the larger genus Polygonum. Today, however, the smartweeds are treated as a distinct genus Persicaria. So we've had a change in name of the smartweeds from Polygonum section Persicaria to just Persicaria. So a change in rank led to a change in the name. But it doesn't stop there in this case, because that change in rank from section to genus has a cascading effect on a whole lot of names at the species level, because the genus is now changed from Polygonum to Persicaria. So we have many Polygonum names in plants like Polygonum pennsylvanicum that we're going to have to change to Persicaria, and this one will have to be Persicaria pennsylvanica. There are also name changes due to circumscriptional changes. What you're looking at there is either one or two species of sweet clover. One species with white and yellow flowers, or two species identified by whether the flowers are white or yellow. Currently in plants, we treat those two photos I showed you, we treat those two things as one species under the name Mellilotus officinalis. When we update plants, we're going to have to treat the yellow and the white species as separate species, because that's the prevailing thought today. So we'll have two sweet clovers, a yellow sweet clover, Mellilotus officinalis, and a white sweet clover, Mellilotus alba. Sometimes a species will have a stable taxonomy, but nonetheless it will have to change its name. Such is the case with an impatient species in the Pacific Northwest. That species was long known as Impatiens ecalcarata. However, further research showed that there was another species in Myanmar that also took the name Impatiens ecalcarata. Two species cannot have the same name. Therefore, one of those species had to give up that name, and that was the species in the United States, since it had a later name. It was the later name. So that one had to change its name, and the name given to it was Impatiens ecornuta. So for a synonym summary, I just want to go over the two main types of synonyms and explain their differences and some of the database challenges they provide. Homotypic synonyms, I showed those with a triple bar symbol, are just that. They have the same type, two names that have the same type. They're objective synonyms. That means they will always be synonyms in any taxonomic treatment. Just which one is accepted and which one is treated as a synonym can vary. These are usually due to changes in rank or position, or both, or a rules violation, such as the impatiens example I gave. Heterotypic synonyms, as in the sweet clover or Mellilotus example I gave, are due to differences in circumscription in different taxonomies. Do you circumscribe that clover with yellow and white flowers as one species or two species? The heterotypic or subjective synonyms provide a bit of a challenge for databasing because if you just use the name Mellolotus officinalis by itself, it's not clear, are you talking about it broadly circumscribed with yellow and white flowers or narrowly circumscribed with simply yellow flowers? Those are the photo credits. I'll be happy to answer any questions during the question and answer period. Thank you.